We can operate in active mode or we can operate in saturation mode or cut-off, and last one is decoder. Now let's say that the transistor and its characteristics. So here, from the characteristics, what we are going to learn. Very important. If you have a graph of the characteristics graph, what we are going to refine or what we are going to draw the information from the graph is important. So if you have a graph, it is drawn between x and y axis, but what we should take in the x axis and what we should take in the y axis is important. Okay? In the x axis usually we will take the voltage and in the y axis we know that we will take the current. This is called VN characteristics we have studied in time. Now coming to the input characteristics and output characteristics. As we have seen, the transistor consists of two diodes. Input is one diode and output is also active between another diode. There are two diodes in the transistor. So if you are drawing here the input diode, what is the diode current and what is the diode voltage? What we are applying? That is important. Now coming to the configuration. This is your picture for common base configuration, right? Base is connected to ground. Now tell me, what is the input current for this? When base is connected to ground, what is the input current? Input current emitter. So input current is what? Emitter current. Okay? Repeat after me. Input current is emitter current. Output current is current. Now input current is emitter current, right? And input voltage is what? We are applying between what and what? Measuring between emitter, that is wrong. Now, what should we maintain constant? If we are drawing input current and input voltage, we should maintain the output voltage as constant. Okay? So what is the output voltage here we are measuring? This is voltage between collector and base. Okay? Maintaining VCD as constant. So VCD is equal to, if it is 5 volts, we are getting the graph like this. If we increase VCD to 10 volts, VCD is equal to 10 volts, then the graph shifts towards a very low value. Means your plugging reduces. Where is it starting? A little bit early in the graph. So this is about input characteristics. And now coming to the output characteristics. So here, your output current is IC. Output voltage is VCP. Okay. Now, what is the units for current? Whether it is emitter current or collector current, yesterday I told you. Milliamps or microamps. For emitter, milliamps. For collector also, milliamps. But if we take base concern, base is right area, base area is millimeter, so microamps. So here, what is the units I should take? Milliamps. Okay, in volts. This is in volts. Now, this is about the input characteristics. We got the graph. What we have to find out? First thing is, from input graph, we have to find out what is input resistance. Input resistance is Ra. We know resistance is equal to voltage by current. What is the voltage here? VAB is your input voltage. So, VAB by IA is your input resistance. Okay. Now, if you have taken the dynamic resistance, I have to take. So this is the static resistance. Means at a particular voltage, what is your current? At a particular point, what is the voltage and what is the current? But if I take the dynamic resistance, then I have to write delta VB by delta IA. So what makes the difference? If it is static, I can take at one point, but if it is dynamic, I have to take difference of the voltage to the difference in the current. Now from the graph, we have found the input resistance. Similarly, from this graph, what we are going to find out is output resistance. Now output resistance is denoted with R0 for common base configuration. What is your voltage here? Output voltage? VCD. What is your output current? IC. So change in the voltage to changing the current will give you your dynamic resistance, dynamic output resistance. Now, from this graph also, we can also find out one more parameter, that is amplification factor. Amplification factor is beta. What is the amplification factor for common base? What is the symbol generally? For common base, alpha. For common emitter, beta. For common collector, gamma. So here, output current by input current will give you the amplification factor, right? So alpha is equal to output current is what? IC. Input current is I. Change in the output current or change in the input current will give you amplification factor is. For DC means you have to write simply IC by IE. For AC means you have to write delta IC by delta IE. Right. Now we are going for common emitter configuration. If emitter is characterized ground, we are calling it as common emitter. When emitter is grounded, what is your input current? Base is the input current. What is the output current? Collector. So integrate this one. This is your collector current. This is your emitter current. Now base is your input current. Now when base is your input current, so here this is the graph between input current and input voltage. So VBE. Now what is the supply voltage? When you are giving terminal to the base terminal, your supply will be VB. What is your supply when you are giving to collector? This is VCC. Here also can we mention this one? What is the supply voltage? VCC. What is the emitter supply voltage? VEE. Right? Now, if you are drawing the input, drawing the graph between input current and input voltage is input characteristics. Maintaining which voltage constant? Maintaining output voltage constant. What is your output voltage? Between collector, voltage between collector and which terminal is grounded? Emitter. So VCE is your output voltage. So maintaining VCE is equal to constant. 20 volts will get the graph like this. Maintaining VCE is equal to volts. What is the difference you are observing? V common emitter configuration and common base configuration. Here, when I increase the voltage, my cutting voltage point is being reduced. But here, when I am, see, they both are equal. When here I am decreasing and here I am increasing the cutting voltage. So your cutting voltage has been changed because we have to imagine which terminal we are giving to. Okay, as here terminal is emitter is grounded, so your cutting point goes on increased because your base is very likely. Now let us go for the next one. In output characteristics, there are three regions. I have reminded you active mode, cut-off mode and saturation. Now in this graph also we are going to see these portions. When I go give any voltage to both the junctions, you will not get any current. So this portion is called cut-off region. Okay. When your input voltage VCP is low and you have made output diode also powered by both are powered bias and your VCP is very low, then also current flows even in the negative voltage. So this portion is called saturation. Okay. When your input is powered bias and output is reverse bias, then this portion is called active. So in the output characteristics graph, there are three modes of operation we can see. When we are giving both the junctions reverse bias, no current flows, and this is the region. This dark portion is the cut-off region. When your voltage both are common bias, even your input voltage is also very low, negative also. Since output junction is also common biased, you are getting some current. Okay? So this current portion is below is that will